All right, so today we're talking about what are the different properties of limits and like how they kind of work. So work through both of these on your own and then we'll talk about it. Okay, so this first one, we want to find the limit of f of x first. So plug in 2 and we'll get 3 times 2 minus 2, or you'll end up with 4. And then if we do the same thing for the g of x here, plug in 2, we're going to add on 2 times 2 or plus 4 to get an answer of 8. Now the second one, similar idea, but you want to combine the functions first. So we have our limit as x approaches 2 of this plus this, so you're going to end up getting 5x plus 2 because you add them together. And then plug in your 2, so you get, this needs to be minus 2 at the end. 5 times 2 minus 2, which then still gives you 8, if you can see it. So the lesson or takeaway from this is when you combine limit functions, it doesn't matter if you combine the two functions together first, like we did in the second half, and then take the limit, or if you take the limit of each one separately and then combine them. So if you have like limit of this plus limit of this, you can take the limit separately and then combine, or you can combine the functions first and then take the limit. Same with multiplying, dividing, subtracting, all that kind of stuff. So some more examples. So we're given here that as we approach 8, the limit is 5 of f of x. As we approach 8, the limit of g of x is negative 2. So if we're going to do subtraction here, we want to take the limit of f is going to be 2, the limit of g is going to be negative 2, and you'll end up getting 7. What's the next one here? The limit of f of x is going to be 5, limit of g of x is negative 2, positive 7 stays the same. You end up with 5 over 5 or 1. Same idea here. You have 4, g of x is negative 2, and then here when you have x, you just then plug this x in to get 8, and this will simplify to negative 1. So here's another example, but using a graph. It's going to work the exact same way. So I'll try and do these in different colors. So f of x here, we want to look at when x is 2. So right here, f of x is the red function, so right there. And we have 1. And then if we're looking at g of x, do it in green, still at 2, g of x is blue, which is right here, so times 0, your overall limit together is going to be 1. So then same idea here, if we have g of x at 2.5, so 2.5 is about right here, red function is at 1, and f of x here at 2.5 is still at about 1, so your limit is 1. And then if we're looking at negative 2, so negative 2 right here, we want the limit of this in the red, so it's just going to be right there, which is 1. And then if we look at the g of x, so subtracting g of x, still right here, right there at negative 1, your limit will be 2. All right, so I want to find this limit. Use your calculator for this point. Make sure that you have it in degrees, otherwise it will graph it wrong. So if you graph this, you should get something like this with like a hole right here. And this is 1. So if we look at this limit from each side, we're going to get 1 for the limit. How do we prove that? How do you know that's always true? So you won't have to do this on your own, but just as an FYI. If we're looking at this right here, the blue, right, is obviously the smallest shape. So that's right here, the area of that. Our sector is right here, and that's the middle or the black. And then obviously the red triangle is going to be the biggest, so that goes at the end. So this is just listing out areas by how big the shape is, which kind of makes sense. And then you want to figure out how can you replace that. So the area of a triangle is 1/2 base times height. Here, we're looking at this with an arc radius of 1. So if we're looking at our triangle A, B, C, right? We know that this chunk is part of the circle, so that has to be 1. So then x is cosine, y is sine. So x would be your base, and this would be your height. So you end up getting 1/2 base times height is cosine sine. Similar idea for over here. We have 1 is your base, because that's all the way out. And then your height is going to be your opposite over adjacent, or your tangent of x. And then you can get rid of the 1/2 on all of the sides to get to here. Divide everything by sine to cancel some of these out and get to this point. And then if you take the reciprocal, so you flip it, that changes your sign, but we get to this point. Now if you take the limit of everything, limit of 1 over cosine, plug in 0 right there, you get 1. Plug in 0 right here, you get 1. So we get 1 and 1 on either side, which then means that in the middle, it also has to be 1, meaning that limit has to be 1. So remember that. It's going to show up in your homework. It's going to show up on the test. You need to have this memorized of what is the limit of sine of x over x. It equals 1. Just memorize it or look it up on the test. It's up to you. Okay, so finding this limit. Here, we're not going to go through the whole proof a bunch of times because that seems like useless work. So you can break this up. So I can rewrite this one as the limit as x approaches 0 of cosine of x times the limit as x approaches 0 of sine of x over x. This first chunk, or the second chunk here, we know this is 1 because that's what we just proved. And then for the first chunk with our cosine, if you plug in 0, cosine of 0 is 1. So 1 times 1 is 1, and that's your limit. So a similar idea with this one. We can break this up into the limit as x approaches 0 of 2x over x, and then the limit as x approaches 0 of 3 sine of x over x. Here, make sure you have the x on both bottoms because you're adding and subtracting here. You're not doing multiplying, so you can't assign the x just to one of them. So we'll get limit as x approaches 0 of 2 when these x's cancel, plus the limit as x approaches 0 of 3 times sine x over x. So this first chunk is going to be 2. This chunk is going to be 1, and this is going to be 3. So you end up getting 3 or 5 as your final answer. Again, check on Schoology to see what your homework is. It may be different than this.